Hi, everyone. We are now going to use these ideas in order to work out this problem. We're going to use polynomial long division to divide the top polynomial, the dividend, by the bottom polynomial, the divisor. In 2.6, we're going to look at this as rewriting a rational expression. Now, there are a couple of things that we don't like about the polynomial on the top and on the bottom. For one thing, the polynomial on the top and the polynomial on the bottom are not written in what form? These are not written in descending powers form. And usually that form is very helpful. So I would recommend writing these in descending powers form. But there's another issue. These two polynomials are both missing a term. What term are they missing? They're both missing an x term. So it may help us accounting-wise to actually write out a plus 0x. We call that a missing term. Writing out a missing term. We're calling that putting in a missing term. So these are two things that will help us out. Writing the two polynomials in descending powers form, and also writing in the missing terms. So let's do that. Now, technically it's an optional step, but it's really, really helpful to write the descending powers form. So on the top, we have 6x cubed plus 3x squared, and eventually the minus 5. On the bottom, we have the 3x squared first, and then the plus 1 at the end. Many students also benefit from writing the missing terms, especially the plus 0x in the numerator, or the dividend. The plus 0x in the bottom, students may not need that as much, but some students may benefit from that as well. As you do the homework, try to figure out if you really need the plus 0x in the divisor. Many students benefit from the plus 0x in the numerator, because if you don't do that, you tend to misalign your columns. All right, so descending powers of x, and I would suggest putting in the missing term placeholders. All right, so let's begin the long division. So again, we put the dividend, the numerator, the top thing, inside that symbol. We put the divisor, the denominator, the thing you're dividing by, the divisor here, that goes on the outside. Again, many students benefit from putting in this missing term, the plus 0x, in the dividend. Some students may also benefit from putting that in the divisor. But for other students, it might just be a bother. So do the homework and see what works for you. But remember, you want an accurate answer. So be accurate. More than anything else, be accurate. Okay, so remember, in old school long division, when we divided 9 by 4, we found the quotient. We asked, how many times did 4 go into 9? That is, when you divide 9 by 4, what happens? What's the quotient? Well, here, we're going to be looking at the leading terms. The leading term of the divisor is 3x squared. The leading term of the dividend inside is the 6x cubed. Informally, we're asking, how many times does 3x squared go into 6x cubed? Right. Although that's a bit awkward to say. More precisely, we want to work out this quotient. What is 6x cubed divided by 3x squared? What's the result? The result is 2x. And that's going to be the leading term of our quotient. It may not end up being the entire quotient, but it will be at least the leading term of our quotient. Now, we're going to try to line up like terms. So I'm going to put the 2x in the x term column. And that's one of the reasons why it's helpful to put in the missing term, the plus 0x, because it reminds you that something's there. At the very least, if you don't put in the plus 0x, at least leave a blank space in there. Don't put the -5 here. Leave a blank space in there so that you have an x term column. But again, it's a good idea to put the plus 0x here, and then you put the 2x in the quotient up on top. All right, so once again, the leading term of the top, 6x cubed, divided by the leading term of the bottom, the divisor, 3x squared, we get 2x, which goes into the quotient. It may not be the entire quotient, but it's the leading term of the quotient. All right, so once we got the 2 here, what do? We multiplied. We found that 2 was the quotient here, then we multiplied the divisor and the 2. 4 times 2 is 8, so we multiply. So here, what do? We take the 2x, we take the 2x here, and we multiply it by the entire divisor. So let's do it. What do you get? 2x times 3x squared is 6x cubed. 2x times 0x is 0. Again, for some students, this is a bother. Other students can use it well. 2x times 1 is 2x. All right, so once again, multiply 2x by the divisor, and we're going to write the product on the next line. Again, I encourage you to line up like terms to avoid confusion. The missing term here can be helpful. All right, so we multiply. Again, 2x times 3x squared is 6x cubed. 2x times 0x is 0. I'll write it as 0x squared. So for students who like to go thump, 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 it might be good to have the 0x out here. 2x times 0x is plus 0x squared. So you have something in the x squared term column. And then 2x times a positive 1 is a positive 2x. That goes in the x term column. Again, it's a good idea to put the plus 2x over here instead of over here or over here. So that's where these indicated 0 terms, these written missing terms, can come in handy. Whether or not the 0x here helped you or not, that depends from student to student. Many students benefit from this, and sometimes students benefit from this. All right. Now, we have the product. What do we do then? 2 times 4 was 8. And what do? We subtracted. We subtracted the 8 from the 9, the dividend. All right. But here's the thing, folks. You are much better than adding than subtracting. I'm telling you that right now. You are much better at adding than subtracting. So when you subtract something, what are you doing? Right? 9 minus 4. How do you rewrite this as an addition problem? Well, it's 9 plus what? It's 9 plus negative 4. So to subtract something, you add its opposite. So here's what we're going to do. I'm going to take the opposite of this middle line here, and then we're going to add. We're going to combine like terms. Remember, we must subtract the product from the dividend. People have an easier time adding this than subtracting. So we're going to take the opposite. We're going to flip the signs on each of the term of the product. When we take the opposite, you flip each of the signs on the terms. All right. So here's what we do. We have a big step here. I encourage you to cross out that product and then write down the opposite. So instead of positive 6x cubed, we have negative 6x cubed. Here, it doesn't really matter, but let's call it minus 0x squared. The positive 2x becomes a negative 2x. I know some students might micromanage and they might do this, minus, minus, minus. I think that looks a little sloppy and confusing. I think it's better if people do this. And remember, the key thing is to be accurate, to get the right answer, and to show correct steps. So when doing your work, I encourage you to do all this. It might seem like additional writing, but remember, you want to get the right answer. It really helps. So when we subtract all of this, we're adding the opposite. I'll do this in green. When we subtract, we're adding the opposite. And once again, you're much better at adding than subtracting, because at this point, you just have to combine like terms. All these things I've circled in green, you just have to combine like terms now. And that's a lot easier to do than subtracting. Combine like terms. Again, you're much better at adding than subtracting. When you're adding, you're basically combining like terms. All right, 6x cubed and negative 6x cubed, bye-bye. Your result is 0. That was the whole point, right? 6x cubed divided by 3x squared was 2x, okay? And because of all that, we end up with a 0 over here. 3x squared and, well, this thing here is just 3x squared again. A 0x and a negative 2x, that gives a negative 2x. Again, you're much better at adding than subtracting. Because a lot of people, if they try to think, what's 0x minus 2x, it's easy to mess that up. We get negative 2x. Carry down the negative 5. In fact, I might want to extend that line down there. We're combining all the like terms. Don't forget the constant term here. Don't forget the negative 5. Bring that down as well. So that's why I like to say combine like terms. You don't want to forget the negative 5. All right. Now, in a way, we can think of this as the new dividend. Think of this as the new dividend. And we basically repeat the process. So we have here, again, 3x squared. Do this in, how about blue? 3x squared is the leading term of the divisor, once again. Look over here. What's the leading term of our new dividend? It's going to be its twin, 3x squared. This should be straightforward. What is 3x squared divided by 3x squared? What's a guy divided by its twin? It's 1. And no, there's no hidden restriction issue here. It's 1. All right. So that's going to be another term we're going to put in the quotient. The positive one goes here in the constant term lineup. All right. So once again, 3x squared goes into 3x squared once in this sense, in this quotient sense. We put the positive one over here as the new term in the quotient. And then what do? We multiply. Once again, we multiply. We multiplied the divisor by the positive 1. Of course, when you multiply all of this by positive 1, you're just copying it. All right, so we get the copy. 1 times all this, you just get the copy. 3x squared plus 0x plus 1. Again, the 0x here helps to line things up. If the 0x here helps, great. It helps some students more than others. And again, what do? We've taken the product here. What do we do with this product? We subtract it now from that dividend. But remember, you're much better at adding than subtracting. When you subtract something, you're adding its what? You're adding its opposite. Add the opposite. So I'm going to cross this out and flip all the signs. Again, some students might just do this, but I think that's a little micromanagey. There we go. I cross this out. Well, I write the opposite first, then I cross it out because you might cover up some negative signs here. So we write down the opposite, negative 3x squared minus 0x minus 1, then cross that out. Combine like terms. We're adding the opposite, combine like terms. So we're adding this and this, combine like terms. 3x squared and negative 3x squared, bye-bye. Negative 2x minus 0x, negative 2x, we get this guy again. Negative 5 minus 1, Hey, you're in Vegas, you lose $5, you lose $1, you've lost $6. Frankly, in Vegas, you're lucky if you only lose $6. But here you go. We end up with negative 2x minus 6. In a way, that's our new dividend. But I have another name for this thing. Because we're finished with this part of the process. It turns out this will be the what? Back up here, what do we call the 1? We call the 1 the remainder. And I claim that we can call this thing here the remainder. Negative 2x minus 6, this will be the remainder. How do I know I can call this the remainder? Well, what is a remainder? What is acceptable as a remainder? When can we stop this process over here? Well, if we either get a 0 or if we get a polynomial with degree less than the degree of the divisor. All right. What is the degree of the divisor? The degree here was 2. What's the degree of this remainder? Negative 2x minus 6, it's linear. The degree here is 1. And 1 is less than 2. That's very basic math. 1 is less than 2. The degree of the remainder now is less than the degree of the divisor. So this is an appropriate remainder. If this is 0, we're thrilled. But otherwise, we want a polynomial whose remainder is less, whose remainder has a degree that's less than the degree of the divisor. All right, so we're done with this part of the process. And then what do we write? What do we write? Remember what we did over here. The long form was, well, 9 divided by 4 was the quotient 2 plus the remainder over the divisor, right? It was the quotient plus the remainder over the divisor. The quotient plus the remainder over the divisor. 2 plus 1 over 4. Over here, let's do it. What's the quotient? The quotient is going to be, up here is 2x plus 1. That's the quotient. Plus a fraction. Because the remainder is not 0. We're going to get a fraction. On the top, we put the remainder, the negative 2x minus 6. On the bottom, we put the divisor. And we can remove the missing term now. 3x squared plus 1. In fact, it's conventional to not have missing terms. Don't put the plus 0x. And we should be good. A quick check. This fraction over here, remember, better be what? I call it bottom heavy by degree. I call it bottom heavy. Because remember, we either get 0 here, if the remainder is 0, or we get a rational expression that is bottom heavy, meaning that the degree of the numerator is less than the degree of the denominator. They cannot even be equal. The degree of the numerator must be strictly less than the degree of the denominator. The degree of the remainder must be less than the degree of the divisor. The degree of the top must be less than the degree of the bottom. All right. We have degree 1 over degree 2. That's good. We get a proper bottom-heavy rational expression. In addition to this quotient. Remember I said in addition. Put that plus sign there. Put that plus sign there. All right. So here's the form. Quotient plus remainder over divisor. I just wrote this. And again, to reiterate, don't forget the plus sign. Don't just stick these next to each other. I know with this mixed number, 2 1/4, we put these things next to each other. Don't do that here. You need the plus sign. All right. Or if you don't have a plus sign, what you could do is you can factor a -1 out of the top, and then it becomes a minus sign. But basically, you need either a plus sign or a minus sign over there. All right. Okay, so although I would accept this, since the leading coefficient is negative up here, it's conventional to factor out a -1. So you get the opposite of 2x what? It's the opposite of 2x plus 6. You're flipping both those signs in there. And then you can pop out that -1 factor. So the more conventional way of writing this is the polynomial in descending powers, 2x plus 1. And then when you factor out a -1, the plus changes to a minus. And we have 2x plus 6. That's a plus sign there. 2x plus 6 over 3x squared plus 1. This looks a bit nicer, but I'd accept this as well, personally. All right, we performed the long division. The long division. So when you divide this top polynomial, when you divide this top polynomial by this bottom polynomial, you get this result. In other words, you can rewrite this rational expression as this, and we're going to see the impact of that later on. Now you might be asking, is there an easier way to do this? There is if the divisor is very nice, something like x minus 2 or something like that. If you have a very nice divisor, then you might be able to get away with synthetic division, and that's next. Again, up here, watch your signs, all right? And also, if there are any common factors on the top and bottom, cancel them out. For example, if you have x as a common factor on the top and the bottom, cancel them out. That's somewhat rare, but it happens sometimes. And watch your signs. All right, once again, next up, if the divisor is very nice like this, you might be able to use synthetic division as an alternative. That's next time.